look at intersecting chords. Now, remember that a chord just connects 2 points on the circle. It doesn't have to go through the center. So let's take a look. There's a couple of theorems that we want to go through before we start working some of these problems out. So the products of the lengths of the segments of the intersecting chords are equal. So if I have my picture here and I'm going to have two chords, and it doesn't matter where they are, we just know that they're going to be intersecting. Okay. So we have a chord here. We'll call that chord AB is going to intersect chord CD here, and they intersect at a specific point, okay? Right there, we'll call that M. So then AM times MB, so the two segments multiplied together, that's product, is going to be equal to DM times MC. Okay, so that's what that means. The products of the lengths of the segments of the intersecting chords are equal. So that's the theorem there. The second one, or the next theorem that we're going to look at, is that vertical angles are formed by intersecting chords are equal in measure. So just like vertical angles when we talked about parallel lines and a transversal, this still is going to apply because the vertical angles really just applies to intersecting lines. Well, since chords are line segments, intersecting line segments would produce vertical angles. So they're and vertical angles are congruent. So let's take a look here. So again, if I have chord A, B, and chord D, C, so let's see here. Let's name these A, B, and D, C. Then this angle, they meet right here at M. So angle CMB is going to be equal to AMD. So angle CMB is going to be congruent to angle AMD. All right, and then and likewise for the other two angles. So any two angles, so like this angle here would be congruent to this angle on this side as well, because it's still a vertical angle. And then the adjacent angles are formed by intersecting chords are supplementary. So just like with cosine, when we talked about adjacent, that's right next to, so angles that are right next to each other are going to be adjacent angles. So they basically make up a line and they're going to be supplementary, just like we learned when we talked about parallel lines cut by transversal. So let's have our intersecting chords again. So we have A, B, and then we also have C, D. All right. So this angle right here, so remember they meet at M. This angle AMD is going to add up to 180 with angle DMB. So I kind of said that funky. So here we go. So angle AMD plus angle BMD is going to be equal to 180 because they make up that line segment AB. That just makes, I mean, you guys know that. We've looked at that. It's just a little bit different when you look at it in a circle. And then the last one is that the measure of the angle formed by the intersecting chords is half. So this is the big thing you want to pay attention to, is half the sum of the measures of the intersecting arcs. So also notice that that is plural. There's intersecting arcs. So the intersected arcs are going to be both sides of those chords. So let me show you what I'm talking about. So here's my circle, and then we'll have our intersecting chords. Okay. So basically, this angle right here, so they meet at M, is going to be equal to this arc length plus this arc length divided by 2. That's half of it. Okay. So we're going to have angle AMD is going to be equal to 1/2 times the sum, which means add, the arc length of AD plus the arc length of CB. All right. So those two arc lengths, same thing. If I wanted to find other angle measures, it's just half the sum of those two arc lengths. And we're going to look at this a little bit more closely in our examples. All right, so this example one refers back to that last theorem we just talked about. So we're trying to find the measure of DSA. So I'm trying to find this angle here, okay? So this angle, so angle DSA is going to be equal to half the measure of arc DA plus the arc of CB. That's how we find the angle of that of intersecting chords. That's just a theorem here. So the angle DSA is going to be equal to 1/2 times 153 plus 19. So that's going to be equal to 1/2 times 172, which is going to be let's see, 86 degrees is going to be the angle DSA. All right. So um, here we just use that last theorem. So it's half. Inscribed angles are half. The only thing that's equal so far that we have is going to be the central angle. So now let's take a look at example 2 here. We're going to find this chord length, I guess the chord from the intersection to the rest of the way. So what I know from that very first theorem, so the first theorem and the last theorem of what we've talked about a little bit more here, is that we know that this segment or this part from here to here, this x times the rest of it is going to be equal to 10 times 24. Okay, so 15 times x is going to be equal to 10 times 24. All right. So then that's going to give me 15x is equal to 240. And then I will divide by 15 on each side. And so x is equal to 16. So that's just using that first theorem. So far we've talked about the angle of the intersecting chords is half the measure of the intersected arcs, both of them. And then we've also looked at the missing side length is going to be, and so we've talked about the product of this side is going to be equal to the product of these two sides. So now we're going to find the value of x and y. So first off, what I need you to do is I need you to take your little handy dandy little pencil right here. I want you to write 175 right there because we forgot to add the in there. So in order to find x, which I think is easier to find first, so I'm gonna find x first. I know that 18 times 13 is gonna be equal to x times 14. So 18 times 13 is equal to 14 times x. So 18 times 13. So then I have 234 is equal to 14x. Then you divide both sides by 14 and you get 16.7 is equal to x. So we found x. Now I need to find y. So I'm going to take back that original or go back to that very bottom theorem that we talked about, and the measure of y is going to be equal to 1/2 times the sum of the intercepted arcs. Well, the intercepted arcs are going to be 140 and 175. So 140 plus 175. So this is going to be half of 315. And so then I'm going to have, so y is going to be equal to 157.5. I'm taking half of the sum of the intercepted arcs. Now, just because we didn't work with or look at a little bit more closely the other theorems doesn't make them any less important. But some of those you've already looked at a little bit more closely because of vertical angles, and we talked about that with parallel lines and the transversal, also supplementary angles. So the big takeaways from here is that you want to know that the product part where the product of each segment is equal to the for the chords are equal, and then you have another one, so one's equal and one is half. So this one, the other one with the angle of the intersected arcs, or excuse me, the angle of the intersecting chords is going to be equal to half of the intersected arcs. And so that's the two big theorems that we worked with a little bit more today. So now it's your turn to practice with either quizzes if you need a little bit more practice, or to move on to your skill check.